Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the substrate. The compound is an octalene 1, 2, 3, 4, 4A, 5, 6, 7, 8, 8A decahydronaphthalene with a double bond between the two ring junction carbons C4A, C8A. There is a methyl group on a bold wedge bond at one ring junction carbon and an ethyl group on a bold wedge bond at the other ring junction carbon. Moving on to the next step. Identify the reaction. OSO4 followed by NiHSO3 is a S-yne dihydroxylthione reaction. OSO4 adds across the double bond in a concerted S-yne, same phase fashion to give a CIS diol after workup with NiHSO3. Moving on to the next step. Determine the phases of attack. The double bond is between C4A and C8A. OSO4 can attack from either the top phase or the bottom phase of the double bond. The existing substituents, methyl at C4 on a wedge is equal to above the plane, ethyl at C8 on a wedge is equal to above the plane, define the two faces. Attack from the top, same side as methyl and ethyl, gives one S-yne diol, and attack from the bottom, opposite side, gives another S-yne diol. And for the final step, consider the stereochemical outcomes. Since both substituents are on the same phase, both on wedge bonds is equal to both above the plane, the two faces of the double bond are diastereotopic. Top phase attack gives one diastereomeric product, and bottom phase attack gives another diastereomeric product. These two products are diastereomers of each other, not enantiomers, because the molecule already has stereocenters that make the two faces non-equivalent. Count distinct products. Since OSO4 is achiral but the substrate is chiral, both existing stereocenters are defined, top phase and bottom phase attacks give two distinct diastereomeric diol products. No racemic mixture issue arises here beyond these two diastereomers because the starting material is a single enantiomer, defined stereochemistry at both ring junctions. Why other options fail? Option A, 10 and C, 3 and D, 4 are incorrect because there are only two faces of the double bond and S-yne dihydroxylthione on each phase gives exactly one product per phase, totaling two products. Therefore, the correct answer is B. Therefore, the correct answer is option B.